Hi, welcome to section 1.7. We are dealing with transformations of functions. This is something that you guys did in Algebra 2, but I just want to go back through and make sure we're set with these ideas. Our intro for today I want to talk about them. We're going to graph three functions, and I'm going to make all three of them a different color so that we can graph them. You can use your calculator, and I'm going to do this just briefly without my calculator, but you can use your calculator. If you look at x squared, you have the points of 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4, and you end up getting this parabola. Okay, so that's this first graph of y equals x squared. I'm going to change my color and then make a second graph. I'm going to do this second one in red. X squared minus 3, if you were to put this in your calculator, you'd get a point 0, negative 3, 1, negative 2, and 2, 1. And I'm just going to plot these points real quick and draw this parabola. So here's the second one. And then I'm going to change my color one more time. Let's go green here a minute, and we'll do this third one. X squared plus 4. The vertex is going to be 0, 4, 1, 5, and 2, 8. And so let me plot these as well, and you end up getting another parabola. And the goal is to take a look at what happens. As you look, in the second graph, you'll see that the entire graph shifted down 3. So the negative 3 at the back means go down 3. Okay? The positive 4 at the back, if you look at it that means go up 4. And so that's the first idea. And that is actually something we kind of expect that you remembered from Algebra 2. But if not, again, your graphing calculator is there. Our goal for this, though, our goal is to be able to look at an equation and describe the transformation. And I'm going to say shifts. Describe the shifts without using your calculators. And that's kind of our goal for this lesson. So I'm going to do the other one with you too, and then we'll get into some general ideas. I'm going to start the x squared in green this time. So this is the y equals x squared graph. I'm going to change my color again. The second one, I'm going to do it again. We put in our calculators, and you end up getting this graph. Okay, so you get this parabola. And then I'm going to change my color one more time to do the third one. And you end up getting this graph. Okay, so taking a look, our goal is to kind of figure out then what happened. If you see inside the parentheses the plus 2, which is the second graph, our blue graph, what ended up happening, we moved left 2. Okay, and then if you notice the x minus 3 squared graph, this ended up happening where we then moved right 3. Okay, so I want you to kind of keep and look again. What ended up happening here? Well, normally a plus 2 we would say go to right, and so you may want to make a little note here that it goes the opposite of when it's inside the parentheses. Okay, so opposite when inside the parentheses. And we'll kind of leave it like that. Okay, we're going to give you some general information about shifting left, right, up, and down. And then from there, we're going to actually ask you about reflections. Okay, so here's what happens. If we're trying to shift up, then what we're going to do is take the graph of f of x, and we're going to add a value of c to the end. If we want to move down, then we're going to take whatever our function is, and we're going to minus c from it. If we want to go left, left and right are opposite of what we think. Remember, they're also in parentheses. So we're going to go in our function, we're going to take x, and because it's left, I want to say x plus c. And if we shift right, we'll say x minus c. And again, this goes in the parentheses and it's opposite of what you think. So we're going to give you an example of how that works. Okay, so let's look at x squared plus 2x. What happens if I shift down? Well, I take my function, and we're going to call this, actually I'm going to do it this way. We're going to take our function, and if we're moving down, we're going to go minus 7 at the end. And I'm going to call this new function an h, just to basically say, listen, I shifted my graph, and so I take my f function, which is x squared plus 2x, and I'm just going to take a minus 7 at the end. For part B, if I'm shifting it left, then I take my function and I do x plus 12 in order to go left. What that means then is everywhere I see an x, I'm going to put an x plus 12 in, and I'm going to call this a new function h again. So everywhere I see an x, I'm going to put an x plus 12 squared plus 2 times x plus 12. Now, normally we would ask you to simplify that. For now, I'm going to leave it there. Okay? The third one says, can you do both? Well, sure, I can go left 12 by putting an x plus 12 in for the x, and then I could subtract 7. And I don't have a ton of room on my line, so I'm going to put it right here a second. So my new function is x plus 12 squared plus 2 times an x plus 12, and then a minus 7. Now, normally, again, we would ask you to simplify, but for time here, I'm going to leave it, and I'd rather that you get the general idea. But again, we would normally ask you to simplify it. Okay, if you have questions about this in class, again, please let me know. I'm going to go to the next type, which is reflecting. And if we want to reflect over the x-axis, then what I'm going to do is I'm going to call a new function h. And if I reflect over the x-axis, let's say a point is up here, a point that's xy. If I reflect it over the x-axis, I get down here, this point is x negative y. And so you'll notice then the y value is different. And the normal way we say y value is f of x. So it's going to be the opposite of my original f of x value. If I want to reflect over the y-axis, let me draw a similar picture for you. Here's the point xy. If I reflect it over the y-axis, I get to this point here, which is negative xy. And so you'll notice the x value is the opposite. So my new function h is going to be the function of f with a negative value, or the opposite value of f. Okay, and our goal is to figure out, given the function f of x is the square root of x, how could that equation look if it's first reflected over the x-axis? Well, if I reflect over the x, please remember we're going to make it the value of it negative. So what I'm going to do, where's that negative f of x? I'm going to say then this new function h is the opposite of my original function. And if I'm reflecting it over the y-axis, we said we were just making the value inside negative. So my new function for h is the square root of the opposite of x, or a negative x. And again, normally we don't square root negatives, but I just want you to keep in mind kind of as to how the process works. Okay? Go ahead and flip the page. and we're going to do a little bit of a mix. Okay. Our first graph, x squared, we've done a couple of times already. Let me quickly put that graph in. You'll notice it is a parabola. So this is that first x squared. And then I'm going to change my color again. And I'm going to do my second one in blue. Now, I'm going to actually describe the transformation first because I want you to get to the point where you can do that just by looking at this equation. So this plus 4 means you're going up 4. And the negative in front means you're reflecting over the x-axis. Okay, now you do have to say over the x-axis because now we have two types of reflections. So here's what I'm going to do. I'm going to first reflect it because normally we multiply order of operations before we add it. So I'm going to flip my graph first, and at 0, 0, flip still stays at 0, 0, and then I'm going to move it up 4. And if I take the second point and flip it, it would come down here, and then I'm going to move it up 4. And I'm going to take this point and I'm going to flip it, and then I'm going to move up 4. And I'm going to take this next point and flip it, and then move it up 4. And so then you can kind of see what happens. And this is actually a perfect no calculator question. But again, if you can't, you do have your graphing calculator to help you get the second function. Please, though, get in the habit of doing the transformation without your calculator so that you're ready to go. I'm going to do the second one too. We again are talking about the normal x squared graph. This is our parent function of a parabola. And then I'm going to switch my color again. This, let's describe again first. The plus 3 inside is the opposite, so that means we're going left 3. The negative out front means again we're reflecting over the x-axis. Okay? So take a look again. Here's our original graph. And I'm going to start with the left 3 because it's in the parentheses and then make it the opposite. So I'm going to go 1, 2, 3 to the left for 0, 0. There is no flipping there, so here's my first point. And then I'm going to move, let's do this one. 1, 2, 3, and then I'm going to flip it across the x-axis. Move this one. 1, 2, 3, and then I'm going to flip it across the x-axis. And then let's go 1, 2, 3, and flip it. And then 1, 2, 3, and flip it. Oop, let's try the right point. Nope, I'm good here. Let's change this one. Sorry about that. And we'll actually flip that one. And so you get this parabola. Again, your calculator can do all of that work for you, but truthfully, it's going to be so much more beneficial to you if you can get in the habit of doing this without your graphing calculators, because later we do take your calculators away. Okay. Let me slide this down to the last portion of our transformation. We're talking about non-rigid transformations. And basically, here's the thing. I'm not going to use these terms so often, but your book will, and I want you to know them. Rigid transformations basically means the shape, the shape doesn't change, only the location. Okay, so horizontal shifts and vertical shifts, so going left, right, up, down, and reflecting, they don't change the shape of the graph, they only change where we locate them. Okay, so we're moving them left, right, up, down, and then reflecting them. So we're not changing the shape, we only change the location. That's why they're rigid, they're not changing. Non-rigid transformations change the shape, okay? And this is done by stretching, and we're going to talk about stretches and shrinks kind of as we go through. And so I want to talk about the absolute value. If you need the absolute value in your calculator, in your y equals menu, then hit the math button, go over to, I believe it's number, and then the first thing you see is ABS. And that will help you do this absolute value. So I'm going to graph the basic absolute value graph. And you'll know absolute value keeps everything positive because it describes a distance. And so this is my first absolute value graph. Let me change my color to do the second one. This second one, we talked in Algebra 2 about the number in front of an absolute value being the slope. So this number in front is the slope of 3 over 1. So I'm still going to start at the point 0, 0, but then I'm going to go up 3 and over 1 and plot my point. Up 3 over 1, plot my point. And you end up getting up 3 over 1 in both directions. You end up getting, I think, what you guys would describe as a skinnier graph. What ends up happening is we say this stretches vertically. It's trying to stretch itself away from the x-axis. Okay. The third one is 1/2. So this has a slope of go up 1 over 2, and I do it in both directions. And then from that point, up 1 over 2, up 1 over 2, and you end up finding then that you have a wider graph, okay? And that wider graph we actually call a shrink, okay? Because this ends up shrinking itself towards, it shrinks itself towards this x-axis line, okay? So it's shrinking itself towards. So as I look at this, and I put a number in front, if I look at a value of C and I put this number in front, I will get a stretch if C is bigger than 1. So like the value of 3 or a value of 4, 5, 6, okay? It will shrink if C is between 0 and 1. At 1, it's just going to be the regular absolute value graph, that green one. But if it's a between 0 and 1, like a 1/2 or a 1/3, or even a 0.7, it can be in decimal form, but if it's between 0 and 1, it'll shrink itself down towards the x-axis. Okay? That's the idea of a vertical. And vertical, don't forget, vertical means you stick it in front. Okay? So vertical does the in front type. Horizontal puts the value right in next to the x. So you'll see the C is right there with the x. And so I'm going to show you that. I'm going to graph the normal x cubed graph. So 1 is 1, 2 is 8. So -1, -8. And you end up getting this curve. Okay? Let me change my color. If at any point I'm going too fast, please feel free, pause it. Make sure you're on the same page with me. The second graph is 2x, and so what I'm going to do is put that in 4x and then cube it. Please remember exponent rules, you have to cube both, so it's 8x cubed. And so I'm going to graph this 8x cubed. So you still have this point at 0, 0. When I put a 1 in though, when I put in a 1 in here, 1 cubed is 1 times 8 is 8. And so I end up getting this graph. And a lot of people say it's skinnier, which is fine, but you'll notice this is what we call a shrink. Because like the last one when it shrinked towards the x-axis, in this case you'll see it shrinks towards the y-axis. So if we want a horizontal shrink, we want our value of C in this case to be greater than 1, and you'll notice it's kind of an opposite. If it's with the x and it's bigger than 1, it's a shrink. If it's in front of the x and it's bigger than 1, it's a stretch. Okay, let me change my color. We'll do one more. 1/2 x means I take 1/2 x and I cube it, which is 1/8 x cubed. So I still have 0, 0. And then at 1, I get like 1/8. And at 2, 2 cubed is 8, times 1/8 is 1. And you'll kind of see that it'll stretch out farther. So it'll go like this. And this is a stretch because it's stretching away from that y-axis. So a stretch occurs if C is between 0 and 1 when you're talking horizontally. Okay. These are the hardest, the non-rigid ones are the hardest ones of the day because it's figuring out these rules right here. And a flashcard idea would be a great idea to make sure you kind of know all of the rules. This is going to continue from chapter 1 on to chapter 5, 6, 7. I mean, we're going to use this every single chapter we go through. I'm going to go down just to the last example just to make sure that we're set. If I want a vertical, and it doesn't matter stretch or shrink, but if I just want something vertical, vertical goes out in front of my function. So c times f of x, which means this new function h is 2/3 times the absolute value of x. So vertical, and truthfully, don't worry about the word shrink or stretch. It really, at this point, doesn't matter. But they're saying if I want it to be vertical, it's got to go in front of my function. If I want it horizontal, it has to go in my function, so f of cx. And that ends up being then this new function h of x is the absolute value of, is it 4x? Okay, so it's got to go inside my function. And that's kind of the idea that we're trying to get you to see. Vertical is outside of my function, horizontal is inside of my function. So, thank you for watching 1-7. Please be ready with questions on any of this. And we're going to be working in class on stretching, shrinking, and getting to the point where you can give me an equation, give me all of the transformations if I give you an equation.